Good afternoon, everyone. Today we will be continuing our course Applied Geomechanics for Geologists, and we will talk about vertical stress. This is our lecture plan. It includes 3 topics. Let's go to the topic number 1. Is definition of overburden stress. Knowledge of the in-situ stress state is important component of any work related to petroleum rock mechanics. And recognizing its critical role, the oil and gas industry is increasingly using new techniques such as mini-frac testing or core plugging strain. This is to manage and estimate maybe in situ stress conditions. The magnitude of overburden stress is equivalent to integral of rock densities by the depths. In other words, overburden stress is called the weight of overlying rocks. Let's consider 3D porous solid with volume delta X, delta Y, and delta Z. In this case, equilibrium requires the summation of all force in all directions to be 0. So, equilibrium of forces in vertical direction must be equal 0. Considering infinitesimal variation yield the following equation. This is integral of rock density by depths from daily surface to a definite depth z. If rock density is constant, then vertical stress may be a function of depth. This is multiply of rock density G and true vertical depth Z. That is principal figure of definition depth on offshore and onshore. Let's consider it. A Kelly bushing is a mechanical device that transmit torque from the rotary table to the Kelly, which is a hollow square of hexagonal pipe that is used to drill oil and gas wells. Okay, so for onshore, this is Kelly bushing level. It's distance from Kelly bushing to mean sea level, MSL. Ground level, this is density from ground level. Ground elevation, this is density, the distance from ground level to mean sea level. True vertical depths below ground level equal true vertical depths without Kelly bushing minus ground level. True vertical depths equal true vertical depths Kelly bushing. This is vertical depths from definite depth Z to Kelly bushing. And MD is measure distance from Kelly bushing to definite depth Z by the cable. And for offshore, this the Kelly bushing elevation. This is distance from Kelly bushing to mean sea level. Mean sea level in this case is seabed surface. True vertical depth is vertical distance from Z to Kelly bushing. Water depth is bathymetry. True vertical depth below mean level is vertical distance from Z to Kelly bushing, and true vertical depth subsea, vertical distance from definite depth Z to mean sea level. Okay, let's go to the topic number 2. It's called as Overburden Stress Prediction Methods. On this slide you see density porosity tool. If you can see here, this is a radioactive source emits gamma ray into the formation where they interact with minerals and fluid. So gamma ray returns to detectors where they are contained and their energy level measured. This is main factor of measurement density by the depth. The most common minerals on Earth and feldspar and quartz with particle densities of 2.56 and 2.65 gram per cubic centimeter respectively. And however, the particle density of many common rock forming mineral range from 2.16 gram per cubic centimeter as for salts, for example, to 2.8 gram per cubic centimeter for talc, with the exception of mineral containing iron, such as tourmaline, olivine, sphalerite, pyrite, magnetite, hematite, with densities ranging from 3 to 5 gram per cubic centimeter. So the average density of clastic rock, that the most interesting for us now, near 2.3, 2.4 gram per cubic centimeter. Clays like kaolinite are typically slightly then dense than quartz with densities in order of 2.6 gram per cubic centimeter. The wet bulk density of rocks depends on the total porosity of the specific sample. So rocks of similar type have a broad range of bulk density due to difference in porosity. Please note the chart of changing of density on the common minerals, rock types and soils here. Okay, let's go further. So density log is usually not recorded at shallow depths. This is a problem for geomechanics because calculated profile of overburden stress must be calculated from all density. So some empirical method can be used to estimate shallow formation bulk density. For example, this is Traugott and Aff equations. The equations, please note the equations in low part of this slide. Please note this equation for calculation of vertical stress for onshore and offshore. For the offshore, the addition of water pressure included in the equation. In offshore, without this addition. So to calculate overburden stress, the first step is to build density profile with a depth. After integrating this composite density, overburden stress and overburden gradient can be calculated. Please, it should be noted that the density log may be affected by the borehole quality. When the borehole has washouts or breakouts, the density tool can give a reliable density measurement. In this case, the density log data need to be corrected before using it for overburden stress calculation. On this slide you see any additional equations to calculate overburden stress. It's enough reliable source of calculation of overburden stress, and let's see on next slide the example of this using. This is compartment overburden pressure from density as integral by depth and from true vertical depths. As you can see here, this is very good accordance between overburden pressure from density as integral and overburden pressure from true vertical depths. I decided to show you value units conversion for total stress because maybe it's not enough convenient, because any specialist work by pascals, megapascals, another specialist work with PSI, atmosphere, bar, etc. This table can be useful for recalculation and conversion value units into each other. So similar value unit conversion table for stress gradients. It can be recalculated from, for example, gram to cubic centimeter to PSI foot to specific gravity, etc. At last, we went to topic number 3, overburden stress calculation in LithoStudio software. Let I show you video. I recorded this video recently for show you how can we use LithoStudio software for calculation of overburden pressure and overburden stress gradient. Sorry. Please note that the tracks with the first track is density, second track is overburden pressure, and last track is overburden stress gradient. This is reference and books that I used by preparing this lecture. And this presentation made with SlideGo templates. Thank you, SlideGo.